Hello, welcome. In this video, we are going to be looking at data analysis and interpretation. And specifically, we're going to be looking into exploratory and descriptive data analysis. Meaning of exploratory data analysis. Exploratory data analysis, EDA, is an approach for data analysis that is preliminary. It tries to explore a given data set to give insight into the distribution of each variable. Objectives of exploratory data analysis will include the following: to maximize insight into a given data set. This can be achieved with measures of central tendencies like mean, median, and even mode, and measures of dispersions like standard deviation, variance, and quantiles. Another objective is to uncover outlying structure in a data set by trying to find out if a given data set has a meaningful pattern that can provide useful information about variables that make it up. The techniques that can be used to realize this include scatter plots and cross-classifications. Exploratory data analysis also helps to detect outliers and anomalies, and this is realized by employing techniques that help to observe shape, like symmetry versus skewness, discontinuities, and kurtosis. It also helps us to develop parsimonious models. Let's look at skewness. Skewness and symmetry are very important exploratory measures in a data analysis, and the two go hand in hand because one technique measures both symmetry and skewness. This is because if a variable is symmetrical, then it's not skewed. And if it is skewed, then it is not symmetrical. There are graphical and non-graphical techniques that can be employed to determine skewness or symmetry. Types of skewness. There are two major types of skewness. You have negative skewness or left skewed data, and you also have positive skewness or right skewed data. Negative skewness or left skewed data. For data to be seen to be negatively skewed or left skewed, as is shown in the diagram below, the left tail should be longer. The mass of the distribution should concentrate on the right of the figure after plotting the graph. The peak of the data should be at the right, and the data should appear as a right-leaning curve. Even though it's a right-leaning curve, it's also seen as a negative skewed data or negatively skewed data. It describes negative skewness or left skewed data. Let's look at positive skewness or right skewed data. For data to be seen to be positively or right skewed, the right tail should be longer, and in this case, the mass of the distribution should concentrate on the left of the figure, as you can see here. The peak of the data should be at the left, and the data or the figure that is given rise to by plotting the data will appear as a left-leaning curve. Even though it's a left-leaning curve, it shows positive skewness or right-skewed data. There are ways of calculating skewness. You have the graphical approach, and you also have the non-graphical approach or means. Non-graphical means of calculating skewness. Calculation of skewness has been developed by several authors, including Pearson, a notable statistician, and the rule of thumb to skewness based on Pearson's statistical measure of skewness is as follows. If skewness is less than -1 or greater than +1, the distribution is highly skewed. If skewness is between -1 and -half, or between +half and +1, the distribution is moderately skewed. If skewness is between -half and +half, the distribution is approximately symmetrical. Graphical means of calculating skewness. This entails drawing out the pattern as represented by the data point. We have shown this in our earlier explanation of types of skewness. It was a diagram which resulted from plotting the data points, and we use it to show negative skewness, positive skewness, and symmetry. Let's look at the relationship of mean and median under differently skewed distribution. The first one is positive skew. Positive or right non-parametric skewness. In that case, the mean is greater than the median. So you can see the mean is greater than the median. And the median is greater than the mode, which is the peak. For symmetrical distribution, that's the second diagram or figure. The mean, the median, and the mode are equal. And in this case, the distribution is said to have zero skewness. Negative or left non-parametric skew, as we have here. In that case, the median is greater than the mean, and the mode is greater than the median, which is the peak. Kurtosis. Kurtosis is a statistical measure that defines how heavily the tail of a distribution differ from the tails of a normal distribution, and is an important descriptive measure of data distribution. Kurtosis determines the heaviness of the distribution tails. Types of kurtosis. You have the mesokurtic, which is kurtosis of 0, leptokurtic, positive excess kurtosis, platycutic, which is negative excess kurtosis. Mesocutic, like kurtosis of 0, it's a data that follows a normal distribution, as you can see. Data that follows a mesocutic distribution shows an excess kurtosis of 0 or close to 0. As earlier said, it means that the data follows a normal distribution. Leptocutic. Leptocutic indicates a positive excess kurtosis. The leptocutic distribution shows heavy tails on either side, indicating large outliers at both ends. Platycutic. A platycutic distribution shows a negative excess kurtosis. The kurtosis reveals a distribution with flat tails. The flat tails indicate the small outliers in the distribution. Let's look at stem and leaf plots as an exploratory statistical tool. Stem and leaf plots is actually a procedure in SPSS for Windows, and is a special table where each data value is split into a stem, the first digits or digits, and a leaf, usually the last digits. The figure below shows an analysis of the SPSS window and results of exploratory analysis. After analyzing data or in the course of analysis, and you want to use stem and leaf plots, you go to SPSS and you go to Descriptive, Explore. One time you click Explore, and then you go to Explore Plots. You will see the stem and leaf plots. Descriptive analysis. We're going to be looking at meaning, graphical analysis, and non-graphical means of explaining descriptive analysis. Descriptive analysis or descriptive statistics are used to analyze a given data set in order to find out the basic features of the data set. And the major gains of descriptive analysis lies in its ability to reduce huge amounts of data to easy to understand summaries. Graphical means of descriptive analysis, one of them is the bar chart. The bar chart uses solid bars on an X and Y axis that extends to meet a specific value indicated on the chart and can be shown either vertically or horizontally. These charts are flexible and are most commonly used to display data from a frequency table of responses. Below, this diagram shows an example of a bar chart. Another graphical analysis is the pie chart, or also called circle graphs. It has colorful slices that represent segments of data, and the total percentages of the segments always add up to 100%. This is a pie chart. Non-graphical analysis, we're going to be looking at frequency and cross tabulation. Frequency show the possible responses, the total number of respondents for each part, and the percentages of respondents or responses who selected each answer and lots more. The table below is a frequency table of gender. You can see it. Example of a frequency table is on gender. You have male and female, their percentage, their valid percent, and their cumulative percent. Cross-tabulation is another very powerful descriptive analysis tool. It's also known as crosstabs. It's a good way to compare two groups of information. It's just like doing two frequencies together. Crosstabs allows one to compare data from two questions to determine if there's a relationship between them. In this case, if you want to test that hypothesis, you can use a cross-tabulation chi-square. Like frequency tables, crosstabs appear as a table of data showing answers to one question as a series of rows and answers to another question as a series of columns. When you want to run SPSS cross tabulation, it's easy. You click Analyze Descriptive Cross Tabulation. SPSS will open a window that will enable you to choose the row and column variables as well as other options. It has abstract statistics cell format where you can choose your options that you wish to be included in the result of the analysis. When you finish providing the information required, you just click OK. And the result of the cross-tabulation will be displayed at the output window. This is an SPSS Win cross-tabulation window, which shows opportunity to include rows and variables. You have the abstract statistics cells format where you can choose your options. You can also divide your cross-tabulations into layers. And this is the result of SPSS cross-tabulation. It's cross-tabulating gender with educational qualification. For male, you have 56, while for female, who are SSCE or below, in terms of qualification, which is senior secondary certificate education, total is 81. You have percentage within education, and so on. With this, we'll come to the end of our lecture on exploratory and descriptive data analysis. In the next video, we shall be looking at practical demonstration of exploratory and descriptive data analysis in SPSS. Bye.